What's going on, you guys? Today we're going to work on counting bits. It's a medium Leetcode problem, and so it looks like they want us to solve it in O of n time and O of n space complexity. So let's go ahead and read this and figure out what they're asking. So given a non-negative integer number num, for every number in I, or in the range 0 to num, including num, calculate the number of ones in their binary representation and return them as an array. So like take 1, take 2, take 3, take 4, compute the binary representation and then sum the number of ones in the binary representation. So 4, for example, is 1, 0, 0, so that's 1. 5 would be 1, 0, 1. So that would be 2. And so we have an example here. So 5, as I said, 2. 4 is 1. 3 is 2. 2 is 1. 1 is 0. Or 1 is 1 and 0 is 0. Okay. So let's think of a let's first think of a brute force solution. So a brute force solution would be to just loop through each of the numbers between 0 and num, and for each number calculate the binary, sum the digits, append it to an int array, or set that value's int array to the sum, and then return that array at the end. So it looks something like this. So let's think about this. So binary bits count. Let's call this just an array. So this is just some pseudocode. And then for value in 0 to num, including num, we're going to calculate binary of value, sum the digits, append the sum to binary bits count, and then return binary bits count. And so what is the space-time complexity of this? So this loop is O of n, or O of num, and then this operation right here is O of, like it says here, the size of value. So the brute force is going to be O of num times the size of value, right? And so the goal here is to try and get a solution that's just O of num. So whatever num you get, it should be proportional to that. So let's think of an efficient solution. Okay. So let's take a look at 1 through 10. Like how many bits does each one of these have? So 10. I believe we can do that with 4 bits. So 10 is, what is 10? It's 8 and 2. Zero, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. Okay, so that's 10. So let's take a look at the binary of the first 11 digits. So 1, let's just copy this. 2, 3, 4, 5, 6, 7, 8, 9, and then we have 10. So 9, 8, 7, 6, 5, 4, 3, 2. Four, 5, 6, 7, 8, 9. Okay, so let's see if anything stands out here. Okay, so let's look at, so this is 2 to the 0, 2 to the 0, this is 2 to the 1, this is 2 to the 2, this is 2 to the 3. And so you see that all powers of 2 have exactly 1 bit. And 16 would just, it would work for 16 as well. So that's something. So if we could do a rule like if num modulus, if num is divisible by, if num is the power of 2, if num is the power of 2. There's no, okay, let's keep looking. So that was interesting to note. So 8 divided by 2 is 4. And they have the exact, they have both 1 digit. 4 divided by 2 is 2, and they both have 1 digit. 2 divided by 2 is 1, they both have 1 digit. 6 divided by 2 is 3, and they both have 2 digits. 10 divided by 2 is 5, they both have 2 digits. Okay, so maybe we could say if num modulus 2 equals 0, then binary bits count of num equals binary bits count num divided by 2. So binary bits count of 6 equals binary bits count of 3. Binary bits count of 2 equals binary bits count of 1. And then what if it's an odd number? Three integer division, 3 divided by 2. Integer division is 1. So it has 1 more than 1. 5 divided by 2. Integer division is 2. So it has 1 more than 2. 7 divided by 2 is 3. So it's number of digits of 3 plus 1. 9 divided by 2 is 4. So 4's digits plus 1. Else, binary bits count num equals binary bits count num divided by 2 plus 1. Does that work? Seems to work. So we have this theory that this is how it would work. We would test it by just running like a bunch of examples. Like the computer, we could just say, hey, do this for like 10,000 digits. Let's see if this holds true. And I assume that's how Leetcode does that. They have a bunch of tests in the background that will do something like that. All right, so let's try and code this. So all right, so our efficient solution is going to be for value in 0 to num. Okay, first we're going to initialize, so we're going to say binary bits count. We're going to initialize it to an int array. So we're going to say we're going to initialize the first two values to 0 and 1, right? Because the bits in 0 is 0, the bits in 1 are 1. And that'll allow us to build off of, we can start at 2. Binary bits count of 2 equals binary bits count of 1. I guess we just need to start with 0. Because then when we do 1, when num equals 1, it'll go here. And so binary bits count of 1 equals binary bits count of 0 plus 1, which will be 1. Okay. So we just need to initialize the first value. And then when we get to 2, it'll go here. Binary bits count of 2 equals binary bits count of 1. Okay, cool. Okay. So if num, I can just go like this. Okay, so what's the time complexity of this? It's just O of num. Right, because this comparison happens really quick. It's a constant time comparison or operation right here. Alright, so let's try that. Okay, so var, well, would it be a var or a val? Val you cannot change, but I don't know. Does that mean you can't? Yeah, I think that means you can't change the value. So We're going to call binary bits count equals int array. Need to initialize it to num plus 1, right? Because num minus 0 plus 1, that's the number of digits within this range. And I believe it gets initialized to 0. We can be explicit, we can say it initialized to 0. So it initializes every single value to 0. Okay. For value and 0 to nums. So it loops through every single value, including nums. Oh, it's num. Num. Okay. What do we want to do? If num modulus 2, so it's the remainder when you divide by 2, is 0, so it's a even number, we're going to say binary bits count of num equals binary bits count num divided by 2, else, let's just copy this. We add 1. So I'm not sure, I don't remember in Kotlin if I have to put this in parentheses. So we're going to try it. If we can just add those if we get a compile error. So and then we're going to return binary bits count. And so let's think about what if num is 0. If num is 0, we'll get an int array with 0 in it, right? Okay, so this should work. Let's see. No. Okay, so what do we do wrong here? Oh. Value. 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 So num doesn't change, it's just the same number every single time through the loop. So value, it iterates. Let's see. There we go, guys. So space complexity, it's O of n. It's just the size, or O of num. Just whatever the size of num. So if you get 1,000,000, you're going to have space proportional to 1,000,000. And time complexity of O of num as well. There you go, guys. The brute force solution is O of num times the size of each value. And the efficient solution is just O of num. All right, thanks for watching. Stay tuned for the next episode.